Hopefully everything will go okay technically because I'm presenting from a MacBook. And I still have to figure out some of the things using the projector and stuff like that. So far so good. Today I'll be doing a few presentations on what the DFSee program is, and specifically in the next presentation, this is just a short one. The next one will focus a little bit on what are the new features and stuff, starting from the later versions 9, 10, 11, 12, which is the current one. Just to bring you up to date a little bit, because I think the last time I gave this presentation in the US was 2008, maybe, 2007, not sure. And there's some new stuff. Okay, so let's get going first. What the DFSee program is, and how to use it. Okay, this is me. Just go over that quickly. On the next slide, this is what this presentation is about. What the DFSee is, it's an operating system neutral utility thing. It started out as a disk utility on OS2, but fairly quickly I decided to make it more generic, so I was also able to use it on DOS and on Windows, and later on Linux, and I even have a version running on the Mac with some limitations. And the main purpose I started with was because there were few utilities on OS2 that could really dig down into the file systems and the disk partitioning stuff. Apart from the FDisk stuff that was around at that time, it was fairly limited. And DFSee, I started working on DFSee, I think in 1992, 93, something like that, as an HPFS file system browser, and it evolved to a full disk utility over the years. And I use it mainly myself for partitioning and for making backups, stuff like that, of the partitioning system, and for solving problems with file systems for myself, but over the last 10 or 15 years also for a lot of customers using DFSee. Okay, so what you do with it, you can examine and modify data on your disks, being it partitions or file systems or files or whatever. DFSee is generic in the sense that it just views at things like a large collection of data sectors, so just bunches of bytes, characters, whatever you want to call them. And DFSee can look at those things on physical disks or disk partitions or volumes that you can only access by a drive letter maybe and don't have physical access to. Or on regular files like raw image files that you can take from partitions or disks or maybe from other tools. And you can view data either raw, which is then probably in a hexadecimal format or something else, which is very low level and not very useful for most people. And so there are also a lot of formatted displays in DFSee that allows you to look at partition tables, look at file system structures like directories or allocation tables, stuff like that, for various file systems. Okay, at the moment, this is a rather old presentation, as you can see, 2005. So there have been a few updates. One of the updates is that there's also a Macintosh version, OS X version at the moment. It's a text-based program, so it's not graphical at the moment. I'm still considering to make a Qt version, but that's really a lot of work because apart from the user interface, I also have to update the internals to match that coding for the user interface. So it's a real big task, but it would allow me to have much better support on Linux and Macintosh, for instance, where at the moment I'm lacking mouse support due to the very low level of integration I have in those systems. But it's text-based, and that especially 10-15 years ago, that was almost the only way you could easily run off a DOS bootable diskette or something and have your program run fully functional without relying on anything like Windows or whatever. Okay, so this is what I talked about earlier. DFSee just looks at storage as sectors, large collection of sectors, and on opening things like volumes or partitions or disks, we'll just look at those sectors, and DFSee will look at contents of sectors and see how to best display stuff. As you already see, 6.x version. 2005, so we're on 12 by now.
That went a bit too quick, I think. Let's see if we can go back. Freeze. Right click, that's freeze. Oh yeah, yeah. Let's just go back. Mouse cursor there. Oh, there we go. There's it. There's the mouse. Back.
I did it yesterday.
That's very. This is what it was. So DFSee internally uses a couple of stores, which is just a concept. The store is a bunch of sectors, collection, and you can associate a store with something real, so a physical disk or a device on Linux or a virtual disk, which only exists inside DFSee, or maybe a raw image or a disk partition. The user normally doesn't need to know about stores. It just opens a disk, opens a volume, and looks at it. But this is the underlying concept, and that makes that opens up quite a few possibilities to do things with virtual disk and stuff like that. Manipulate things. I think I went. Okay, I already mentioned this, I think. Associate a store with something real, something physical. We usually do that using the menu. The later versions of DFSee all have a menu system which make operating it a lot easier than the older versions, which just had a command line. We had to know a lot of the syntax and stuff like that to be able to use it. It's still not very easy to use, I must confess, but it's a lot better than it used to be. Okay, the virtual disks are used inside DFSee, and I use them a lot myself because what this enables you to do is, for instance, take information from a real disk, put it into a file. It's called the DFS disk process. Generates a bunch of files. You can send those to me through email or something, and I can import those in a virtual disk. And then I can do most of the analysis and recovery or testing out recovery stuff on that virtual disk. And only when I'm convinced that it's going to work, I can send you a recovery script to run, and it will make fixes to your partitioning or whatever, and then I'm fairly sure that it will work. So this virtual disk is most important for me, but of course anyone can use it in the same way if you want. I may be able to demonstrate some of that stuff later. Well, I'll skip this part because I go right on to the next presentation, which is the later versions and what's new in those later versions. Let's see, get this one out of the way. Let's see what the next one is. There we go. Okay, this is the actual presentation for today. It will show some new functionality in the later versions, and also shows some of the distribution stuff, the CD-ROMs that are still being sold, that are bootable versions with FreeDOS and Linux on them, that you can use to run DFSee on a system that will not boot by itself. And it's also possible these days to create a memory stick, USB stick, that has that same bootable system on it. So you can boot FreeDOS with DFS or Linux from such a memory stick. That's still one of the old ones, but these days I have the smaller ones that you can create your own. There's actually a menu item in DFSee to transform any USB stick into a bootable DFSee one. The only thing you have to do after that is copy a few ISO files, like the latest DFSee ISO that you can download to that memory stick, and then it will be functional. It doesn't work on all systems, unfortunately, but it works on most ThinkPads and other laptops that have the ability to boot from USB devices. Okay, so the whole presentation will be about quickly, who am I? What have I done? I'm a software engineer really. I have an education in electrical engineering, but I have been doing software engineering all my life, really. Started in the 80s, so my main language in programming is C, and later also C++ and Rex, assembly, PHP, stuff like that. But still, 90 to 95% of my work has been in C. And the last 5-6 years I've also done a lot of embedded software development, so for appliances and devices and stuff, electronics that has software in it, and all of that is in C as well. I worked with a consultancy firm for about 15 years, but in 2001 I quit that and founded my own company to develop software on my own and get out of that treadmill of consultancy, and it was just more talk and blah blah than real work. So I decided to do what I like most, and that's software development. By that time I already had a DFSee, which was a freeware thing at that point, and I turned it into a more or less commercial product that's been available for sale through Mensis ever since that time. Okay, we saw this already in the other presentation, so I won't repeat that. It tells you a lot about what you can do with DFSee. It's mainly partitioning and system analysis, system recovery, partitioning, stuff like that. All the presentations are on my website, by the way, so if you want to look at them later, you can download them or view them later. This is one of the main areas, creating and maintaining partitions. So you can use the create and delete commands, or use the menu items that are for the same purpose. It includes support for LVM, which is the Logical Volume Manager that was introduced with OS2 a long time ago already. And a few other partitioning tools on the market support that, because it was an OS2 only thing really. I don't think there's any other commercial tool that really supports LVM outside of the few IBM tools and the tools that come with the Ecom Station these days. There's also a partition table editor, so you can do low-level edits of partition table, but still at a higher level than just the bytes. So you can look at them in a formatted way. You can make changes that go beyond just creating or deleting partitions, but you can specifically change the size to an exact number of sectors and stuff like that, if you need to or want. And then for partitions there are various commands that will alter some properties of the partition, like partition types, and also fix stuff to align partitions exactly on cylinder boundaries, stuff like that, and fix incompatibilities with other tools or programs to make everything run better or without additional problems. Another important thing for using DFSee is imaging. You can copy contents of partitions or whole disks or whatever range of sectors you can select. Copy those to a file that you can store elsewhere or move to another system. And you can also compress those files, so maybe for a 100 gig partition you probably end up with a 20 gig image file or something, depending on what type of content is on the partition. So what imaging is doing is taking one of the things that DFSee can look at, so that's a whole disk or a partition or whatever, and put that into a regular file. So an important thing, and that most people are not really aware of, is that in this sense, DFSee is just an application like any other, and to write that file, the image file, it will need operating system access to store that file somewhere. So if you're running the DOS version of DFSee, there's not a lot of choice. The only thing you can access from DOS or FreeDOS will be a file system. That's about it. So there are a few restrictions in that sense, but if you're running on OS2, for instance, you can save your files on JFS, create huge image files, or you can create them on HBFS and have the 2 gigabyte limit, stuff like that. So it's just creating files for you that you can transfer to other systems or use as backup or whatever. But you have to have access to those files, and also if you want to restore them, same thing. With most operating systems you can also store them on a network, of course, so it's on a server somewhere. But still you need access to those files. There's also smart technology in imaging and also in cloning, and smart means that DFSee is smart enough to look into the file system and skip all the areas that are not really used. So it will know that, for instance, a partition or a file system that's just 10% used, it will only image those 10% and just skip the rest. Because there may be a lot of garbage in those other sectors that maybe don't even compress very well, and you want to skip those, because otherwise your image files get much and much larger than they need to be. One other important thing to note is that if you restore images, and the same goes for cloning, which is the next slide, you can restore them to different objects. So if you make an image from a partition, you can restore them to another partition, but the size has to match. So the size has to be exactly the same or a little bit bigger. It doesn't really hurt, it's just wasting some space then. But, what it will not do is automatically resize a file system to fit in a partition you choose. So if you want to do that, there are some possibilities, but that's a separate step. So the imaging and restoring is always equal size. It has to be the same size. Cloning is similar to imaging, except that with the cloning, both ends of the process are disks or partitions or whatever. So, for instance, if you want to make a backup or move a partition to another one, you could make an image and then restore the image to another partition. The cloning goes directly, so it just takes the contents of one partition and copies it directly, sector by sector, to another partition. Or takes a whole disk and copy it sector by sector to another disk. This is called the disk-to-disk clone. It's the fastest way usually to make a copy or a backup, whatever. For instance, one thing you could do is if you change your hard disk in a laptop, for instance, you just clone the old one, which is usually smaller, clone it to a larger one, and then expand or add partitions to it. It's one thing that cloning is used for a lot, and also I use it a lot for backups. So important data or operating system partitions, I usually back them up on a second hard disk on the system or a USB disk, and just use cloning for that, because it's very easy. Just clone it to the backup disk and then clone it back if you need it. It's just almost as if it's a file copy. Just takes a little more time. Okay, there is some special handling possible for bad sector areas. So if you got a disk that is failing, then you can add some options to the cloning to tell it to try to to retry that sector areas, and also you can also merge things, so you can make a clone where it will leave the original stuff intact and only clone over the correct sectors, so you just skip the bad ones. Okay, the partition to partition clone, I already mentioned those. That's a smart technology. Yes?
So you mentioned starting it as a file for backup, but can you in real time clone it from one drive to another using, for example, a drive tray?
Using what?
A drive tray? You can put
yes.
2 hard drives in a
Yeah.
ThinkPad.
Mm-hmm.
You can do that then.
Mm-hmm.
Is that explained in the documentation?
Yeah, it's cloning, disk-to-disk cloning. So if you got 2 identical disks, same size, then you can just make a copy of that one disk to another, and it will
Okay,
be
but suppose
identical
they're different
copy.
sizes, as you mentioned. You're
Sorry?
upgrading your drive.
Yeah.
Okay, but so the smaller drive would be the one that's in the used in the ThinkPad. You put the drive tray in and put the second larger drive in.
Exactly.
You
yeah.
can either
You can copy both
clone
ways.
it, or you could create it as a file and.
Well, if you create it as a file, you need some storage somewhere to put that file.
Okay, so you wouldn't create it as a file then. It would be directly disk to disk.
Exactly.
In real time.
Because then you don't need the intermediate space.
Okay, and can you, suppose you have 2 machines, can you connect them via a LAN cable, a crossover cable, and clone them that way?
Well, you can, as long as the operating system that you're running DFSee from has network access, because the operating system has to use the network. DFSee is not network aware, so the operating system has to take care of that. But as long as your operating system can see that other disk over the network using SMB or whatever protocol, as long as you have low-level access, you can do that. Probably cloning will not work that way. You could probably use imaging that way, but not cloning, because over a network, using most network protocols, you don't have low-level sector access, which is what cloning would use. So if you want to use a network, you probably have to use imaging. One advantage of imaging, by the way, if you do this, is that the image file, if you store it somewhere and then restore it on the other disk, the image file is also back up. So if you fill something up, you still have that image file.
Yes, yes.
So,
Question, do you need to format, do you need to partition the target drive before you clone it, or?
It depends. If you do a disk-to-disk clone, you don't have to do anything, because every sector on the destination disk is replaced by the corresponding sector of the source
But you need
disk.
the exact same disk size.
Or larger.
Or larger. But
Yeah.
a larger means wasted. Or
Not necessarily. If you do a disk-to-disk clone, then there will be, say you got a 100 gig disk and you copy it to a 500 gig, then there will be 400 gigs that are unused on the new disk. But it's just unallocated space. You can create new partitions there.
okay, but it will not be the
It
target.
will not be
It will not be blown up to the full size.
No.
Okay.
No. There's no automatic resizing
Okay.
anywhere in DFSee.
Okay.
There is some resizing, but just on file systems, and it's a bit restricted.
But
Yes.
then you could enlarge that, after you clone it, you could enlarge that.
With DFSee on some file systems, you can enlarge HPFS, you can enlarge FAT file systems. You cannot enlarge JFS. It's not implemented. So what I usually do, because disks are huge these days, what I usually do is making copies anyway. So I create a new partition, maybe much larger, then copy everything over on file-by-file basis, which also has the advantage that everything is then defragmented. So you got a fresh partition formatted and then copy the data over. And then only if you, and then you can reassign drive letters if you're using LVM on OS2 or ECS. To use the new, bigger partition with your same data, and everything works okay, then you can later delete the old one. If you do it that way, then you have a backup also, as long as you want. And then delete the old one and maybe use that space for something else.
And can you actually do this, like if you booted off the first drive, running an actual OS on it, can you do this underneath it while it's running? Or
Well, you can, but I wouldn't recommend it, because
so you would boot off a third thing. Okay.
yes, that's the best way to do it. But it usually works. I mean, cloning, just copying a running operating system will work, but the DFSee is running obviously, and the operating system is running. So some of the things on the disk will change during the cloning process,
Right.
which means that the copy is not 100% consistent. It will usually work, but you don't know exactly what's wrong. So
Yeah.
it's very much like just switching off a machine and then switching it back on again. Because you've got a running system and it got frozen in some sort of way, either by disconnecting the power or by cloning it over to something else, and then starting it up again. It will probably work. Check disk will probably do a good job of it, but no guarantees, so it's not recommended.
If you're copying, you gave an example of a 100 gig to a 500 gig. But if it was a 100 gig to a 2000 gig, where the sector sizes are not the same between them, is that still clonable?
Well, the sector size are the same, but
they
the cylinder size, so the geometry will be different, and you hit a problem there. Because if you do disk-to-disk clone, then it will, all the cylinder alignments and stuff will be based on the old disk.
Yeah.
So on the new disk you'll have the same. And actually my thing that I use at home for my development, well, I do a little bit of development on the Mac now as well. It has a terabyte drives in it, but it only used the first 500 gigs for OS2 because of the same reason more or less. I could have just created everything new but it's simpler because I don't need that much space on the ECD station anyway. What a terabyte.
Yeah.
So I decided to just leave it at that, and the first 500 gigs is used for Ecom Station or accessible for Ecom Station, and the rest is only used for Windows, which was on there anyway. And I also use that for software development. So.
How about log files, DLL stuff? That's not a problem because it goes on a very low level. When you clone, the cloning is just.
No, that's not really a problem. Locked files or something, that's only
So it's on a lower level, it's copied on a lower level.
Yeah,
it doesn't matter.
file locking and stuff is only known at the operating system level and stuff like that. But if you go low level at the disk, everything is accessible, except for the fact that DFSee does not account for things changing underneath. So you're just copying everything over sequentially. And if, well, things like swap file is no problem, of course, but you never know what's being written back.
And if you're cloning a partition, like sometimes it's confusing what's exactly the same size. Like the numbers don't always match exactly.
Well, they don't match if the disk geometry is different between the disks. So because the disk geometry is the number of sectors per track and the number of tracks in the cylinder. And if that's different, then there may be a few megabytes different. So if you have that, what you could do is make sure the new one is a few megabytes larger than the old one.
So it'll work, it's just you need to be sure there's enough room by a little wastage.
Yeah, a few megabytes wasted, maybe a cylinder or something. And then it will work, because inside a partition there is no sense of geometry really, it's just a bunch of sectors. Yes?
With the USB or the disk, when you boot from that, it gives you a choice at that moment of which operating system you're going to use?
Yes.
That's the first
Actually, what will be on the memory stick, the USB stick, is a grub-based bootloader, which instead of the normal booting of partitions, will offer you a choice of booting ISO files. So, and actually there's a long menu list in there, which I commented out most of it. There's only two choices left, which is the DFSee ISO, which has FreeDOS in it, and also the DOS version of DFSee. And there's an ISO file for, not sure what the exact name is, but there's a small Linux distribution. And you can boot either of those two. And if you boot the DFSee ISO, then you get into FreeDOS and DFSee automatically. If you want to boot into Linux, you first have to make sure that all your Linux DFSee executables are also copied onto the stick, which is something you have to do after creating it. And then after booting Linux, you get into the Linux desktop, which is fully functional. You can even go on the web if you want to. But you can also click on the file manager in Linux and then start DFSee from that. And then you have access to the disks that are connected to the system. Okay, Anything else? Oh, just to get back on the cloning. Oh, let's get back a little bit. There was a question earlier if you need to partition or format or anything. As a summary, if you do a disk-to-disk clone, you don't have to do anything. If you do a partition-to-partition clone, then you have to make sure that on the receiving end you have created a partition already, which is of sufficient size. So the same size or a little bit larger. But you don't have to format that, because the whole contents of the thing, including the file system format, structures, etc., are being cloned over from the other partition. So that's, as a summary, is the difference between partition-to-partition cloning and disk-to-disk.
You could use DFSee itself to create that before you...
Yes, actually, if you use the menu, there are also a few higher-level selections that say copy partition. And what it will actually do is just two things. It will create a partition at your destination where you choose it. You choose some free space area on the disk, and it will create a partition there, and then clone in the contents. So there is a higher level operation. It's called copy. There's also one that's called move, I think. It will do the same thing, but afterwards it will delete the old partition.
And I guess they're smart enough to account for different geometries, so they will, if they create a partition, okay. So
well, more or less, what it will do, the create partition will conform to the geometry on the new disk, and then the partition-to-partition cloning will just fill in the sectors. So yeah.
So will it go up to the next higher, next bigger partition level? So that the
yeah, it would, but that means if you want to do a whole disk that way, that has 5 partitions, then you have to do 5 copies or clones. And when doing that, it's always tricky if the stuff is bootable, and there are probably boot managers that may have all kinds of hidden knowledge about where things are. It usually doesn't work very well. So that's why I usually stick to disk cloning. I'm pretty sure it will work, and then work from there. Okay, then the next topic, file recovery and undelete. That's also a use area. Well, used to be. I think it's less last couple of years, but the two things you can do with this. What this actually does is look into a file system, identify where the directory information is in whatever form it is, whether it's FAT or HBFS or whatever, and know where the sectors are for the file that you are interested in, and then create a new file somewhere and copy the contents over. So it's more or less like a clone of a single file. We'll make a copy of all the related data and create a new file somewhere else. And you can use that mechanism in 2 ways. You can either use it to undelete a file that has been deleted in the file system usually is still there, the data is still there, but the description of it and especially the directory entry of it will be gone. But on most file systems you can reconstruct a lot of that and just create a new file with the correct contents somewhere else. So that would effectively be an undelete. The other thing is, in this way you can get access to file contents that are on file systems that are not accessible from your operating system. For instance, using DFSee, I can copy a file from an NTFS partition without having an NTFS drive. So I just go into the NTFS file system using DFSee and recover the file after finding it in its directory structure and stuff like that, and then copy it to an HBFS or a JFS drive, and then still be able to look at it. Of course, you're working on a copy then. It's not really file access. You cannot use, you cannot open it, you can put it in an application or something. You have to create a copy and then do with it whatever you like. I've been using that in the past a few times to get the things that were hard to get to in another way.
Right. And certain structures can be what is it, kind of rebuilt, I guess you could say, if they're damaged or lost.
In file systems.
Yes.
To some extent, yes. That there is some functionality. It's comparable to what checkdisk is doing on a lot of file systems, or Linux file system check, fscheck.
I was wondering if there was any kind of a guidance about that in the...
Well, there's not that much about it. because what DFSee implements are just a few specific fix commands for specific problems in various file systems. There's no overall thing called check disk or something that tries to fix everything.
Right.
So, because file systems are really complex, and usually the check programs that come with it, the check disk stuff, is good enough. So that's what I use. But there are a few problems that are easily fixed, and sometimes not easily manageable with other tools. So there are a few fix commands and menu items in DFSee, but there's no full check disk functionality.
Now, if you accidentally deleted a whole directory,
Yeah.
this can recover the whole directory, or you have to.
Well, that depends on the file system. Usually not. Depending on the file system, what DFSee will allow you to do is look for deleted files, for instance, and it will make a list of all those. But the directory structure is lost, so you can recover them to somewhere else, but then you have to figure out where they belong. And actually, depending on the file system, it will also recreate those directories, but they will be empty, so you have to place the files where they belong. Then you would know what directories had been there before.
Okay.
Okay.
And that sort of thing you can do in the OS while it's up and running without the problems at the disk level?
Yeah, because you're just reading.
Right.
There's a very small chance that you might hit on a file that is being modified while you're doing it. But that's,
Right.
For deleted files, that chance is about 0.
Right. True.
Maybe reallocate the space. Are you
Yeah.
looking at the long name EA as well in JFS?
Yes and no. I'm not looking at it real time, not while searching for the company, but there's a function in DFSee that will allow to get the long name EA name and store it elsewhere, and then DFSee can use that as well. Because there's some unused space in the inodes of JFS, and I use that to store that one file information. Because normally on JFS and also a lot of other Linux file systems, once you delete files, file name info is gone. Because that,
Yeah, that's why I was asking if you're looking at.
yeah, because on Unix-like systems, there can be multiple file names all pointing to the same physical file. So the directory entry that has all the information about, at least about the name, if you delete it, it's really gone. It's not inside the F node or whatever you have on HPFS or other that also contains a file name. It's really separate because it can be multiple. It's all pointing to the same stuff. And the inode on JFS and on other Linux file systems only contains information about some attributes and about file allocation and stuff like that. So that's still there. The file name is lost. So there is a feature in DFSee. If you open a JFS file system, you can select that from the menu, and what it will do is copy those file names and put it into a reserved area in the inode. And the only one being able to use that is DFSee itself, when it recovers. Because normally, if you recover JFS or other things, it will just make up a file name created from sector address and stuff like that. So it's a cryptic name. And if you run this utility-like thing on a regular basis, then if you have a major problem and you try to recover individual files, then you know that at least on 99% of your files you'll have the original file names available. It's much like the old HPFS file system that had the first 15 characters of the file name were stored in the F node. That was for the same purpose, because if you delete a file there, then the long file name will be gone directly. But the first 15 characters will remain in the F node, which is very useful for recovery. So I made something similar for JFS. It's undocumented more or less, but it's a feature in DFSee. Okay. It's not implemented for all the file systems, by the way. It's mainly for HPFS, NTFS, and JFS, and a little bit for FAT. But FAT is also difficult in recovery because there's not enough redundancy to do it correctly. Usually on FAT, if you delete a file and the files are fragmented, then you're lost.
And on Linux, what file systems do you support? There's like, a whole alphabet soup there. riser?
Not that many,
all the
and not everything. I do have some support for EX2 and 3, and also 4, although I'm not 100% sure yet, I have to do some more testing on that. There's support for the riser file system, and I'm planning some support for newer stuff like ZFS and whatever there is. But the support implemented for those file systems is mainly knowing the internal structure and the file allocation to be able to do smart cloning and smart imaging and stuff with that. And for those file systems, there's no file recovery yet. Because that's a lot more work, because then you also have to interpret all the directory structures and the links and stuff like that.
And what is this, the Mac use for?
It's HFS Plus actually. Yeah, it's also its own file system, and I have very limited support for that at the moment. There is a version of DFSee that runs on the Mac on OS X, but it has the same capabilities as all the others, so it cannot really do much with the stuff on the Mac itself. Well, it can interpret the partition tables because they're also different on the Mac, and on later Windows versions as well. They have GPT partitioning instead of the original MBR stuff.
Yeah, are there newer Windows file systems that you can't deal with?
No, it's not newer. It's not newer file systems. It's a new style of partitioning. Instead of using the classic partition tables, they're using something called GPT, GUID partitioning tables. They're more universal and more capable of using really large disks and many partitions and more descriptive stuff like that. It's a lot better in a lot of ways, but it's different. So, and I don't have full support for that yet. I have read-only support. Maybe I'll be able to show something about that later or tomorrow in the next session when I'll do some more hands-on things showing different versions. Because at the moment on this same system it's running OS X, but it's also running Windows XP, an ECS and a FreeDOS all simultaneously because they're running in virtual boxes. So I could show all the DFSee versions on this one machine. Okay, let's move on. Let's see what time we got. We got until 12, right? So half an hour. Yeah. Partitions, I think we already saw some of that in the previous small presentation. So you can go backwards. Showed that, I think, except that you can see that there's an OS X version now, and there's also some support for Windows Vista, Windows 7, Windows 8, which is getting increasingly difficult to use in a way, because just like Linux and some other operating systems, very concerned about security, so even if you're an administrator of Windows, all applications that you start in a normal way will still not have the administrative rights that DFSee needs to have low-level access. So starting DFSee on Windows is getting more and more difficult. Once it runs, it's okay, but if you just install it and click on it, it will just show you an empty disk because you're not an administrator, at least it thinks that you're not, and you won't see the low-level info. Same thing on Linux, more or less, but once you're an administrator on Linux, you can do anything, unlike on Windows, where even administrators are on a short lease. Okay, that's fine. Don't have to go into much detail about that. Just a quick overview of all the versions, started in 1994, more or less, and 2014 now. 20 years of DFSee. And some of the major improvements. This was an important one, that the menu system got into DFSee, which made it a lot easier to use for a lot of people. And another enhancement in that sense is in version 12, where I decided to split up the user interface to a basic interface and an expert interface, where 90% or 95% of the things you do with DFSee you can do with basic mode, and then most of the menus are less than half the items, and a lot of dialogues miss a lot of checkboxes and stuff like that. It makes it a lot easier to comprehend, especially for most end users. And there's some support now, not complete yet, for the .dot file system, and there's also support for the EXFAT file system, which is something that's probably becoming more important over time, because it's the only way to handle really large volumes using the FAT file system. And actually on memory cards, SD cards over 32 gigabytes, it's actually the desired file system. So other file systems are not supported on those cards. So cameras and stuff like that will use the EXFAT file system. And of course the Mac and Windows have drivers for that, so you won't notice the difference. But ECOMStation lacks a driver, of course, so this is one way that at least you can look at it and do some recovery and stuff like that. So I'm trying to get the EXFAT functionality up to the same level as they have for the other file systems. Okay, then some features that have gone into DFSee since the later versions, version 9. One of the changes I made there was contents-based disk geometry, because disk geometry is a thing that's really keeps haunting everybody. Technically it's not needed anymore. It hasn't been for 20 years at least. But still, because of the way design decisions have been made in the past and stuff like that, and a lot of tools and operating systems react differently on geometry. Geometry is just a rule, really. It's nothing technical. It's really, well, it used to be in the old days, but these days it's just a convention. Like how are we going to lay out our partitions and stuff over this huge range of sector numbers, and it's still laid out as if it were a physical disk with multiple platters and multiple sides and tracks on those disks, which really is not the case. Well, internally maybe, but you don't see that from the outside on a modern disk. And you've got SSD disks these days, which are just memory chips, so no tracks, no platters, nothing, and still they use the same concept of disk geometry. And it's sometimes hard to get the right geometry getting passed to you as an application like DFSee from the operating system, because operating systems usually don't really agree amongst each other what the right geometry will be for this kind of disk. So what I decided to implement is a context-based thing. So it's looking at the partition tables, looking at LVM information to see what the geometry was when those partitions were created or changed or whatever. That works a lot better than just asking the operating system, because it's more often than not it's wrong. Okay, but you can still disable it using switches or using the menu system. If you've got a disk that is not interpreted correctly by DFSee, you can still switch it on.
How do you know?
Sorry?
How do you know?
Well, usually if you get a lot of warnings from DFSee, then about partitions not being aligned and stuff like that, that's an indication that your disk geometry is not correct. Of course, the warnings could also be genuine. I mean, if you create partitions using different tools, then often you end up with partitions that are created in different geometries, and then whatever geometry you'll let DFSee use, one of the partitions will cause a problem because it's not aligned to that particular geometry. So. But remember, geometry is just a convention, and there are not many things that are really having a problem with incorrect geometry. Some things are, like older Windows versions, some older OS2 versions had problems with it. So if you had the wrong alignment on a partition, it wouldn't boot, for instance. So for some reason it was looking in the wrong position there. So it's not that often a problem, but it's a thing to be aware of. Because some tools are very picky, like Partition Magic was very picky about partition alignment. It wouldn't touch anything if it thought it was incorrect. Okay, I had some more Linux support in there, like the ext and riser file system, some grub, the Linux boot manager, display and reporting. And DFSee could generate its own documentation about the menu stuff, but that's more for me than it is for you. Let's skip something. Yeah. Okay, then the scripting. There always has been scripting in DFSee, meaning that everything in DFSee can be done using commands. Even if you drive those through a menu system, it still will execute a command to implement the function. And you could put those commands in a text file and have them executed sequentially. That was the old scripting stuff in DFSee. And it was good enough for a while, but at some point you want to make more intelligent scripts that usually test something and do things based on what it sees, whatever, or make things more robust and less error prone. So I decided I needed a better scripting language, and I've been looking around to use something existing, but it was very difficult to find something that was powerful enough and also simple enough to implement and available on all the platforms that I needed to use it on, which was DOS, OS2, Windows and Linux. So eventually I decided to just build on the stuff I had and add some intelligence to it that allowed if statements and while statements, stuff like that, and some built-in functions to get data out of DFSee and stuff like that. So that was added in version 9, native scripting. There's a separate presentation about that. Depending on time, I may show that later or tomorrow. There's also in the low level, if you look at low level disk stuff using the binary editor, you can also look at it to it as assembly language. So you can look at code, for instance, in boot sectors or the MBR or whatever. If you find it executable on the disk using DFSee, you can disassemble that as well.
What level, what CPU?
Most CPUs, I think, up to well, maybe not the very latest enhancements, but up to Pentium stuff or whatever.
But not XMM, SD, SSD?
No, but we'll do the either 16, 32 or 64-bit instruction. You got those. It's using DI Storm, which is a library, a disassembly library made with someone. Works very well.
And does it understand executable file formats also? You said
No.
exe files. You'd have to know where the execution begins.
Yeah, you're just looking at raw sectors actually,
Okay.
but you can choose to not look at them in a hexadecimal format, but in disassembly format.
Gotcha.
And usually you have to scroll back, forward and backward a little bit to align to the instructions, because you could start in the middle of an instruction,
Right.
and then the display will be wrong. So you have to know a little bit of assembly to know when it's right or not. You also have to select 60 and 32 or 64-bit, and you also do that based on what you see. If it looks gibberish, it's probably the wrong selection. But it's mainly meant to look at stuff like boot sectors and stuff like that. Yeah. It's clicking all the way. Oh, there we go. That was
There you go.
there we go. Okay, version 10 added the bootable USB stick and disk creation, which is actually more or less just a script. So it's written in that new scripting language, and it's using DFSee commands to first erase your USB stick, then partition it, add LVM information and stuff like that. And I also think it starts off with restoring an image file to it, a prepared image which comes with DFSee. And then it will expand that to match the actual size and stuff like that. So it's rather complicated, but it's written in that scripting language. And there's a menu item that will do all that for you. So usually all you have to do is get a memory stick, USB stick,
But
plug it in.
why would I do that rather than just use Yummy to put it out here?
Well, because they're not easily to get.
What?
Well, you mean those, the prepared ones? Or,
Oh, yeah, I don't get any comparisons. Like I say, I download Yummy and
yeah, and
put
you
the
create,
ISO image out there.
put an image on it?
Yeah.
Yeah, he's talking about something else, I think.
No, it's a bootable USB stick.
Yeah. With DFC on it, or?
It's got DFC on it.
Uh-huh.
It's also got the MEG Rescue on it.
Okay, yeah, well, there are different ways. This is just one way
Okay.
to create something that can boot FreeDOS or Linux and use DFC with it.
Yeah.
Of course, there are multiple ways to do the same thing, but this is the
Well,
one
I don't
built
want to
into
use the
DFC.
script because it'll wipe out whatever else is on the stick. Your script.
Yeah, yeah,
Yeah.
everything, yeah.
Needs to get asked for an update. To the script.
That's hard to do.
Your Linux distro, does it have JFS and or HBFS support?
HBFS probably, JFS, I'm not sure. It's a rather dated one. It's pen drive Linux, and it's the ISO I use at the moment is about 5 or 6 years old at least. But you could add your own, because actually what I told before, the bootable USB stick is just it's a boot manager that allows you to boot ISOs. So if you update the menu.lst, which is just in the root directory, it's a text file, you can add your own section in there, saying, okay, on this menu line I want to start that ISO file, and just copy that ISO file. The difficult thing about it is, because it's an ISO file, there's no DFC installed into that, so it's just an anti-Linux. And with the one I deliver, it more or less automatically allows you to start DFC, which is in another directory on the same memory stick. So you just go to the file browser that's on Linux, and go to My Documents or something, depends on what Linux distribution you have, and you'll find the DFC icon in there, you can just click it and it will run. But the way that works differs from different Linux distributions. Okay, scripting enhancements. I updated FreeDOS in that release. Not very. Come on. It's either the mouse or it's really okay. Version 11. Okay, a lot of the lists that are in DFC that are directory listings or stuff like that, but also partitions or whatever, can now be sorted. So you can sort them on name or other properties. It's just a user interface enhancement that makes it easier in some ways to do things. Also sort the things like partition tables. Then another thing, bootable in JFS added some workaround for booting problems when it got mixed up with drive letters. And what it did is add the drive letter that was assigned to the partition to boot, which is normally kept on the econ station in the LVM information, so you can change it. It keeps a copy of that drive letter in the boot sector as a sort of last resort to avoid the OS2 cannot operate your hard disk blah 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 problem if you lose track of the drive letter while booting. So I added support for that for JFS and also for HBFS. And actually 2 or 3 months ago when I started working with the virtual disk stuff, I ran into a problem where actually this turned out to be the solution. For some reason, installing a virtual box, I ended up in a situation where the drive letters were incorrect because not sure if everybody's familiar with virtual box, but what it actually does is put your complete computer disk into a single file, and you can have more of those. So I had 3 or 4 virtual box disks for different installations of Ecom Station. And what I did to copy over some tools was to just mount or attach one of those other disks to my running virtual version of Ecom Station. And of course, because I had assigned originally, I had assigned the same drive letter to all of them, E for Ecom Station. It had to pick another drive letter because it was the drive letter conflict, and it chose something like G or whatever it was. So for some reason it did a checklist on that, and what the checklist does is replace that drive letter in the boot sector. It sets it to G, and the next time I tried to boot, there was a conflict because the boot sector said G, the LVM info said something else, and the config.sys also had the original, so they failed to boot. And it took me a while to figure out that it was because I had a checklist running, manipulating this drive letter, so it was fairly easy to update this. The DFSee fixed boot command has an option now to specify the drive letter that you want to have inserted into that boot sector. Okay. There was also some fixes for the enhanced format stuff. Enhanced format is a term used for SSD disks and also 4K sized sector disks, where the partitions are laid out on a geometry where the cylinder size, which is nothing physical anymore, but the cylinder size is 1 megabyte. And it's being used by most GPT style partitions. It's also used by later Windows installs. And there's better support for that in DFSee now, that you can say, okay, I want to use that method of laying out partitions. And there's display only support for the GPT style partitioning as used by the Mac and by Windows stuff. So you can look at disks like on this Mac, you could look at the disk and see what partitions there are. You can not manipulate them yet. You cannot create new partitions or change them, so you can see what they are. Well, in the old DFSee version, all you would see was sort of a guard partition because there's still an MBR, but it only says the whole disk is being used as a GPT style disk, and the internal structure of that is in different locations, and that's what was being added in version 11, that you could look at that information. And some other thing, reset bad sectors, that's another thing that's sometimes used after cloning. If you got a bad disk, a large disk with NTFS, for instance, and it has bad sectors, and you clone it to a new one, and then everything's okay, except that you still have that 45 megabytes of bad sectors that are still marked as bad sectors in NTFS. While on the new disk, those sectors are okay. So if you want to reuse those, you have to reset that internal administration in NTFS to 0, so that no bad sectors. And that's being implemented for NTFS, HBFS, FAT. So this is after cloning a bad disk to a good one, that you can reclaim those sectors that were marked as bad. And then there were some optimizations for the WPI installer on OS2 on the distribution zip. Actually, it's more or less synchronizing everything more than it was before, because the installation from the zip file for DFSee had a different directory structure than the WPI had. So clean that up a little bit.
You have about 5 minutes left.
Sorry?
You have about 5 minutes left.
Okay, yeah. Well, it's probably close to the end of the. Okay, then version 12, basic and expert user interface. The default is to use basic mode, and I'll show some of that tomorrow. I won't be doing any hands-on today, I think, due to time. But it's a lot simpler to look at and easier to use. And for anything really complicated, you just have to switch to the expert mode. Then there's searching and grab functionality, so search for certain terms and get a list of possible hits, both in the help but also in the output text. So if you got a long DFSee session and you got pages and pages of output, you can search through it, which is often very handy. And also searching in the help is also useful because sometimes you know you want to know something about a certain topic, but it's hard to find in the help or in the menu system. And it added support for the EXFAT file system. As I mentioned, it's okay in version 12.1. Okay, well, this is some generic stuff about features that have been there for a while. But, you can do binary editing. You can have a huge screen. So if you got a high resolution screen, you can have you can use something like 200 columns or something and 80 rows or something. And you have a real huge display of a lot of data. You can search in it, stuff like that. You can, well, it's very flexible, binary editable. More enhancement in the scripting. It's still backwards compatible with all the older scripts, but it has much better error checking, a lot of expressions and looping stuff, conditional stuff. Maybe I'll be able to show some scripts tomorrow. This is the creating of the bootable stick that's been mentioned a few times. And on the next slide you'll see what it looks like if you boot that. This is actually the opening screen of that grub bootloader. Had a specific image made for it, so it's a Linux thing you see. And as you can see, you can select FreeDOS and Parted Magic Linux. And it also tells you where to find the DFSee. So it's not really in the ISO that you boot, but it's on the same memory stick, so it knows where to find it. And you can, if you know how it works, it's very easy to update this menu to add other ISOs to boot, like other recovery stuff. This is how you use it. You boot either FreeDOS. You can actually make it work the way that it also has access to the USB stick itself. But this is a bit tricky because then the FreeDOS needs USB drivers, and the USB drivers that are there are a bit flaky because they're not really officially supported. They're just floating around on the internet, and I'm using them, but it's sometimes you get problems. In that case, you can use one of the other selections that just lets it boot from the USB stick, but only has access to everything else. So the advantage is that it works. The disadvantage is that you cannot store any log files or resulting analysis files or anything on that same USB stick or USB disk.
Is there a size limit on the USB sticks that will accept this?
Sorry, if you?
Is there a size limit on the USB sticks that will accept this? Like 32 gigs or something like that?
I think it's 32 gig, yeah.
Uh-huh.
Because it depends. What I actually do is I restore a prepared image. I think it's from a 32 gig stick. I restore that to your memory stick and then resize the file system to match the actual size. So it will never get larger than 32 gigs. If it is larger, you can still, after doing it, you can still create a second data partition in the remaining space. But it will only use up to 32 gigs. If the FreeDOS one doesn't work very well, and that depends on your hardware, the Linux one will usually do better. And also, I plan to update that Linux thing to more recent Linux distributions to give you access to more file systems and better stuff. It's hard to find Linux stuff that I can integrate into my more or less commercial product without having problems with the licensing and stuff like that. So it's a bit of it is what it is. It's in addition to the actual DFSee program, and I try to make it work as best as I can. But there's not that much I can do in some areas. Okay, that's about it for now. And tomorrow I'll have some information about file systems and more technical stuff. And there will be more time for questions, and I'll do some hands-on with the DFSee. Show the various versions and show what they look like. Okay, so most of the questions will have to go wait for tomorrow because I think it's about time now. This is a quick one.
Thank you.
Was there one other question?
Now it's 12 o'clock, time for lunch.
Exactly. That's what I meant. Yeah. Thank you. See you tomorrow.
Wait, wait, you-
And